Okay, guys, next section here that we're moving into chapter 14. Some of you've learned in geometry before, we're just reviewing it. It comes up a lot in calculus as well, so it's good to go back and review this. Okay, so this is right triangles and SOHCAHTOA. Let's just remember that SOHCAHTOA is I don't know, is that called an acronym? I don't know. Or it's like a memory trick to help you remember what these things stand for. Okay, so stands for that sine is equal to opposite over hypotenuse. Okay, I'll describe what this means in a second. Ca is remind you that cosine C is equal to adjacent over hypotenuse. And TOA is reminding you that tangent or tan is equal to opposite over adjacent. Okay, so if I just give us a random example here, of course this can only be used on right triangles. We'll call this angle capital A, this will be capital B, this will be capital C, and we'll call these angles, I just drew that wrong. Let's try again. So I've got this right triangle. Okay, yes, we can do it like that, that's fine. We'll call this, again, angle A, this is angle B, and this is angle C. This we'll call side X, this side Y, and this side Z. Okay? Okay, everybody with me here? So, if I was doing these are called trig functions of angle A. Okay? The sine, so the sine, an angle measure always goes in the parentheses. Okay, this is always an angle measure. So the sine of angle A would be equal to opposite. Opposite means on the opposite side of the angle, which is also directly across. Okay, so opposite of angle A is the side Z over the hypotenuse is always the longest side. The hypotenuse is always across from the 90-degree angle. So the sine of A would be Z over X. The cosine of angle A would be adjacent. Now, two angles are adjacent here. The two sides are adjacent here. The sides that are adjacent are side X and side Y. So how do you know which side is adjacent? Well, because X is the hypotenuse, so it can't be anything else. Okay, so Y is what's adjacent. So the cosine adjacent over hypotenuse would be adjacent Y over hypotenuse X. The tangent of angle A would be opposite against Z over adjacent, which is Y. And now I've got all these things set up here. Okay. There's going to be a couple styles of problems that they use to help you practice this. Sorry, I just lost my page, so I'm finding it again really fast. The first one is going to be let's say that we had something like this. Uh, 25. Why can't I not remember this? Yes, okay. We'll call this 5, this 12, and this 13. And we'll call this, again, A, B, C. Okay, let's say that I asked you for the cosine of A. The cosine of angle A would be adjacent over hypotenuse. Here's the hypotenuse, it's across from the 90-degree angle. This is my H. So adjacent would be the other side that's next to angle A. So the cosine or ca of angle A would be adjacent 12 over hypotenuse 13. What if I asked you for the sine of, let's say, angle C? Side of angle C, sine is so opposite is 12 over hypotenuse 13. Notice that those are actually the same fraction. Okay, what if we wanted let's move this down a little bit. What if we wanted the tangent of angle A? Okay, tangent is toe opposite 5 over adjacent 12. Again, 12 is the adjacent because of 13 is just the hypotenuse. Okay, so that's pretty easy there. Um, all right, one thing that they might do is they might give you a trig ratio. So they might say sketch this triangle. And they might tell you something like that the tan of theta is equal to 15 over 8. Okay, so first of all, if they're talking about sine, cosine, and tangent or trig functions, you know it's a right angle. Okay, all you need to do is measure which angle theta is, and then fill in these sides and figure out the rest. So let's call this theta. Okay, the tan is 15 over 8. Tan is TOA, which is opposite 15 over adjacent 8. I know this is the hypotenuse. I'll then have to use the Pythagorean theorem, a squared plus b squared equals c squared, to find my missing value here that I'm going to call c. So this would be 15 squared plus 8 squared equals c squared. I don't know where my calculator is right now, so we're going to use this one. Let's see, 15 squared plus 8 squared equals, so I've got that 289 equals c squared. So when I square root both sides, I want to square root that answer, second square root that answer, and I get 17 equals c. So now I've just sketched that triangle. Okay. All right, let's do a couple of these, and then this will be done for the day. So we're going to say find the length of x. All right, the first one's going to be like this. All right, so when you're doing this, what you have to do is based on the angle that they give you, which this one is 20, you have to determine what two sides you have, adjacent, opposite, and hypotenuse. Okay, so the side that's all the way across, this is opposite, and of course the 7 is the longest side, this is my hypotenuse. So I have opposite and hypotenuse, so I know that I'm going to the word so, opposite and hypotenuse. That tells me to use sine. Okay, sine of the angle measure, which in this case is 20 degrees, is equal to opposite x over hypotenuse 7. Okay, now to solve for x, all I need to do is multiply both sides by 7. 7 times sine of 20 degrees equals x. So let me make sure I'm in degree mode during this. I'm not, so let's get down here into degree mode. So my x is equal to 7 times the sine of 20, and I get that that side is equal to 2.39 equals x. Okay, let's do another one here. Let's go like this. We'll draw it kind of inverted this time. We'll put a 14 here. Okay, this time again we got to figure out what we have based off of this angle. Okay, I know that x is the hypotenuse, and this side's right next to, so this is adjacent. Okay, so I got adjacent and hypotenuse here. So that's ka. That tells me that I need to use cosine. Cosine of 50 degrees equals adjacent 14 over hypotenuse x. Okay, now watch the difference in how we solve these two problems. I can't solve for x as long as it's on the bottom. So the first thing I need to do is multiply by x and get it off the bottom. I've got x times the cosine of 50 equals 14. And so now to solve for x, I just need to divide by the cosine of 50. And I've got that x equals 14 divided by the cosine of 50 is 21.78. Yep, that'll be all we have for today.